In this example, we are going to use the loop analysis to find a V0 in the network. The first step in loop analysis is always to define loop current, sometimes mesh current. So we say a mesh or loop current. Normally I start with the meshes that has a given current sources. I will define this as my current I1, and this as my current I2. I define this as my current I3, and this as my current I4. The second step is to write loop equations. For the first loop, the current going through this branch has to be 4 milliamps, so it implies that current I1 that is equal to 4 milliamps. And similarly for mesh 2, the current I2 that is equal to 6 milliamps. Then we can write the mesh equation for mesh 3, so we can write it directly as the summation of the resistance 1 plus 2 plus 1 times I3 minus shared between 2 and 3, that is 1 times I2, and shared between 3 and 4, that is 1 times I4, that is equal to 0. The loop equation for mesh 4, that is 1 plus 2 times I4 minus shared 2 times I1 minus the shared 1k with mesh I3, 1 times I3, and there is also a voltage drop of 6 that is equal to 0. So here are the 4 mesh equations. Then step 3, we can solve this mesh equation. Actually, in this example, because we are looking for V0, we can find V0 by using I1 and I2. Actually, although we wrote 4 equations, but we don't need I3, I4 to solve this problem. So step 4, we can just get the conclusion. Say V0 that is equal to I1 minus I2 times the resistance 2 kilo ohm. So that is equal to negative 4 volts. So we notice that this is a circuit with non-shared current sources. It implies some of the mesh current are directly given.